Hey everybody, this is Larry. This is me going to do an extra bonus question. This is a little bit later in the day, so I'm going to restrict the difficulty to medium and easy. Okay, so you can't really choose both. Alright, it's a little bit later day, so let's just do an easy one then. And then pick a random one that isn't an SQL statement, or maybe this is a... And I probably know how to do it, but I don't want to waste time on stream or on video. Okay, so let's look at this one. 1971, find if path exists in graph. And of course, I just want to point out that now that I have premium, it's giving me random ones that are not premium. So I don't know. RNG, how does it work? Anyway, there's a bidirectional graph of n vertices, 0 to n minus 1. Edges are UV, okay. Okay, so there's no multiple edges and no self edges. Write a path from source to destination. Okay, so this is pretty straightforward. It's a little bit of an awkward easy, to be honest, in the sense that, to be fair, especially at, I don't know, the time of inception of this problem inception, it probably is a problem that you really expected to know. But also one of those things that are very hard to learn if you haven't already done it. So like if you don't have graph, I wouldn't say that you need graph background, but if you haven't done graphs, you're not gonna get this one. So you definitely have to study up. But this is a connected components problem, or there are a lot of ways you would say about it. But at the base, it is a connected components problem, and there are probably a lot of ways to solve it. But there are three main ways that you could solve it. One is depth first search, the other one is breadth first search, and the other one is union find or DSU. I'm not going to go over all three today. How do I feel? Trying to find a coin. Okay, heads I do BFS, tails I do DFS. So let's see. All right, tails. What did I say it was? DFS. Okay, let's do DFS. So let's do DFS and let's give it a spin. Though I would also say that, to be honest, this is when you're given an edged list like this, it does make it easier to use union find, to be honest, where yeah, I mean that's pretty much it, really. That's the only point I wanted to make. Otherwise, it is easier to do in this case that first search from an adjacency list. And so we'll build that list out. So adjacency list is equal to collections.we'll take a list, and then for UV in edges of U dot append V and dot append U, right? So now we're just building a list of edges, adjacency list, right? So then now what do we say? Depth first search. So yeah, let's do a depth first search. Let's just say we have current node. Let's just say we have a scene is equal to set, right? So then now we go. How do I want to write it? It's fine either way, right? So we could even just do something like this, right? And then if node is equal to destination, return true, else scene dot add node. For v in adjacency list of the node, if v is not in scene, then we do a DFS on v, right? Or well, I would say and then we do DFS, then return true, otherwise return false, right? Basically this is saying that we depth first search and we found the path, then we return true. Otherwise we return false, and that should be okay, unless I'm missing some like weird things, and it's very possible. Hopefully. Okay. The other thing that sometimes happens is that because I didn't look at the constraints, but because there are a lot of nodes, so that is one flaw with depth first search that I kind of considered but haven't thought up articulated, which is that depth first search does create a lot of core stack space and stuff like this. So sometimes you may get into performance issues. So I was a little bit worried, and it wasn't that fast, to be honest. But still should be okay. It's just that function calls are kind of expensive on Python and Leetcode, or well, both, but Leetcode kind of especially abuses it a little bit too much. Yeah, this is going to be linear time, linear space, and yeah, and in this case, linear. Well, linear is v plus e, right? So just to be clear, mm, is this? I guess input is only e, but yeah, in this case, the linear time is going to be O of v plus e. Every edge gets looked at least one, both in the processing and in here, and also each node get looked at most one. So yeah, and of course in space you have the adjacency list here, and then the depth first search will have that core stack space of O of v. So hence we have O of v plus e. Cool. That's all I have for this one. Let me know what you think. That's all I have. So stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.